These videos are taking me longer than I thought they would, so I'm going to try a different approach. I'm going to start with them already filled out, and so you can fill yours out. Semicircle function family is, here we are on page 18, and the parent function y equals the square root of 9 minus x squared. What I do want to show you, though, is how we get this, and we get this top half of the circle. If you remember, x squared plus y squared equals 9 is the equation for a circle that has a radius of 3. Okay, well, this particular circle, any circle, is not a function, and so we need to solve for y to make it a function, because when we get y by itself as a function of x, we have a function. When we take the square root, though, we get y equals plus or minus the square root of 9 minus x squared. Keep in mind, the equation that we started with, x squared plus y squared equals 9, is the equation of a circle. Okay? When we solve for y and we get plus or minus the square root of the 9 minus x squared, then we've taken this circle and we've broken it down into a top half, which is the positive square root, and the bottom half, which is the negative square root. That's why we just see the semicircle over here to the left. It's just the positive square root. And so that's how we get that. And so we get the top half of the circle. So we can see that the domain would be all real numbers from negative 3 to 3. We see that the range starts at 0, ends at 3. Increasing from, now don't forget that we're increasing over the x. So what part of the domain are these y values getting bigger? What part of the domain? And it's important to remember that. I know we've talked about this, but it's been a while. So the domain, the part of the domain in which the y values are getting bigger, starts at negative 3 and goes to 0. And then the part of the domain where the y values are getting smaller would be from 0 to 3. Okay? No horizontal or vertical asymptotes. We have two x-intercepts, one at negative 3 and one at positive 3. We've got a y-intercept of positive 3, a maximum value of 3, and a minimum value of 0. If I said where is that minimum value, you would say at negative 3 and at positive 3. Okay? And so there you go for your page 18. That was much quicker. Page 19. I encourage you to pause the video as soon as you see what the transformation is, but page 19 is this transformation right here. Y equals, and this is a semicircle, you can write this down, semicircle, and we have square root of 4 minus x squared and then plus 3 on the outside. Pause the video, here we go. Semicircle, all we did was we took the radius of 2, semicircle, and we bumped it up 3 units. Okay, bumped it up 3 units, and there you go. So we have that point right there at 0, 5, and then the characteristics of this function would be right down here. Domain, range, increasing, decreasing. You should pause the video. I'm going to be taking this off the screen here in just a moment. None, none, none. Y-intercept of 5, max value of 5, minimum value 3. Minimum value occurs at 2 points, yet it is still the minimum value. So I guess I could get all those characteristics in there, and we're gonna move all the way over to page number 20. Okay, see how many more we can get in. So page 20 is the exponential functions that we've been so happy about doing recently. And page 20, exponential, y equals 2 to the x. We know what that looks like. Okay, we know what the domain, you might want to pause and go back, but the domain, range, increasing, decreasing, we know all this stuff. Horizontal asymptote, y equals 0. Make sure you're putting y. Horizontal asymptotes and vertical, you're putting x when we have one. The y-intercept of 1, no max, no min. Okay, even though 0 is smaller than any real number, you always have to have one real number that represents the lowest, and we don't have that. And we also, for a minimum value and for a maximum value, have to have one we have to have one real number that represents the highest real number that it would reach. Okay, so there you go. Page 20, y equals 2 to the x. Don't worry about the verbal description. I need to get rid of that at some point in the future. So there's page 20. Move on to page 21. And you're still okay. You don't have to worry about putting the trig parent function on the back, but that'll be in the next one. So exponential, page 21, pause the video, and here we go. So the key point, this is what we've been doing, guys. The key point here went from 0, 1 to 3, negative 3, and our horizontal asymptote is at y equals negative 4. Y equals negative 4 is our horizontal asymptote. We do have a little bit of work here to find the x-intercepts and the y-intercept, or the x-intercept and y-intercept. I'll let you see the work for that. For this one here, x equals 5, and over here, y equals negative 31 over 8. So when you let x equal 0, okay, so that's doable. And then when you let y equal 0, solving this exponential equation, it's actually pretty straightforward. You equate the bases and then equate the exponents, and you've got x equals 5. Okay, and then here you go for the characteristics. Pause that. I'm going to take it off the screen in just a moment. See if I can get all the rest of these in the next couple minutes. Alright, there you go. From the back of that would be the logarithmic function. Now, this is page number 22, so we're cruising right along here. You guys let me know. If you want me to take more time on these, I will. Just tell me. Send me a note or whatever. Key point, we know that to be 1, 0, because the ln of 1 is 0. And it's the only, we talked about that in class, when you make the argument equal to 1, you get your key point. Okay, so no matter what the argument is, choose an x value that will make the argument 1, and you get an integer value for y, because the log of 1 is always 0. Okay, so that's important. The key point, 1, 0. So the domain, you can see 0 to infinity. Range is all real numbers, and remember we always have for the vertical asymptote, we always have a vertical asymptote. So log functions always have that. Okay, and I'm going to take this off the screen in just a moment. But I did want to say, when you do print out page 23, on the back of page 23 is going to be the trig parent function. So this is the one where you have to pay attention. Okay, so once again, here I'm at 7.5 minutes, so that's good. We can get the rest of this in, and then we'll be calling it a night. So the logarithmic function transformation. Pause the video, write it down, pause the video. On page 23, and again, the back of this page is going to be the trig parent function. So if you can set up your set up your printer to print back to back, it'll make your cosmic catalog look a lot better. Okay, so here we go. Negative ln x plus e. It's a good challenge. So the original function, I will walk you through this one. The original function is ln of x, so that starts here. Okay, that's ln of x, 1, 0. And then we want to reflect x, which we don't have, in the x direction. We don't have that, but we do have a shift to the left e units. Well, remember e 2718, 2718, 2718, you know? 2718, 2.718. Yeah. You got it. So 2.718, we're going to go almost 3 units to the left. So we go 1, 2, and then almost 3 units to the left. And what is that? Well, what is that x-intercept? Well, that would be 1 minus e. Okay, 1 minus e would be the x-intercept. And then, so after we move it to the left, e units, and the asymptote, by the way, is also going to move to the left e units, 2.718. So almost 3 units. So there's that, and then this is what the graph is going to look like now, and before we reflect it about the x-axis. So reflecting about the x-axis, that's where we get the green graph. Okay? And we see, our characteristics, and I'm just about out of time here. And that's about it right there, guys. Back of this is the is the trig function, and I will see you in class.